When you create a class structure, you're going to want to not only include methods, but data members. What data members do for an object is they maintain the state of the object. So when you have data members, that's where you're going to be storing your data that describes that object. Let's take a look. I've got an employee class here, and in that employee class, I have 3 class members. The first 2 are actually data members, fname and department, and they're both strings. The third class member is a method called hire. So this class has 3 class members. The first 2 are data members, which are used to track the state of an object. Say, for example, I have 2 employees, employee A and employee B. So those represent instances of the employee class, or objects. Notice that the first name and department are populated for employee A. They've been initialized to Ed and IS. In the second example, I have 2 data members for the employee B, first name and department. Where first name has been populated, the department has not. That's been undefined. It hasn't been initialized yet. So I can see that the data members allow me to track data about my object. Now, the way that data members relate to encapsulation is that there are 2 aspects of encapsulation that affect how you create your data members. The first aspect of encapsulation is that what you're trying to do with a class is you're trying to combine your data and the functionality into a single entity. That's where encapsulation came from, is the notion of a capsule. So you're taking data and functionality for that data, and you're putting it into a single entity, capsule, or class. Placing your data and your behaviors together into a single entity creates a new data type that we know is called a class. The second aspect of encapsulation is controlling the accessibility or the visibility of your data members. Once you've created this entity, in our case what we've created is an employee entity, you've created boundaries for your data. What you'll want to do is you'll want to use these boundaries to control the accessibility of your entity. Lots of design decisions are based on the idea of where you're going to place a feature. Are you going to place it inside of a class and make it only visible within the class? Or are you going to make it available outside of the class? That's a big decision that all of us have to make. C# gives you the freedom to use any accessibility that you want for any of your class members. But in general, here's the rule. Methods are public. They should be accessed from outside of the class. Data members should remain private so that only the class itself can directly manipulate the data members. Let's take a look at our example again. Notice that the employee class has 1 method. It's called hire. And generally speaking, what you want to do is you want to make your methods publicly available outside of the class, so that if I were to consume or use this class or instantiate from this class, it might look something like this. Now, X becomes a reference type that refers to an instance of the employee class. I can freely call the hire method because hire is publicly accessible, and so I'm free and available to call that. Now, this reference variable, even though it's an instance of the employee object, would not be able to see the first name or department data member. Actually, those 2 data points or those 2 data members would not be visible to the object. And actually, that's the way I want it. I want to keep my functionality publicly available to a consumer of my class, but I want to hide my data members. What that does for me is it gives me much more control over my data points. I have a lot more control about how they get accessed, what kind of data gets passed to those data members, and code that might be runnable once those data members get modified or changed. So actually going in and making all my data members private is a very, very general technique. Let's take a look at what could happen if I actually take a data member and make it publicly available. So what I'm going to do is I'm going to take the department and I'm going to make that a public variable, which is generally not a good design idea, but we're going to go ahead and do it anyway. Now notice the consumer of the employee class, that is an instance of the employee class called X. I can call the hire method, but I can also now call the department variable or department data member, and I'm free to assign it. This is one of the problems with making data members publicly available. Let's say, for example, there's only 3 acceptable values for department: IS, accounting, and HR. You can see that there's no chance for me to validate the data that this user has passed to the department data member. So one of the problems involved in using publicly available data members is the idea that there is no validation available. I don't have the opportunity to check what the user of my class has passed to the department data member. There are many techniques to getting the department data member modified or to read the data member called department. But one of the things we're seeking to avoid is to make the data member publicly available. We're going to be exploring different ways of changing, reading, or writing that department data member.